This is a continuation of integration by U-Substitution. Okay? For this one is special. This one is a situation whereby you see that what? The derivative of the denominator is actually the numerator. Okay? You find out what? The derivative of the denominator is the numerator. Say, for instance, I ask you to differentiate this first one. This number one. Say, differentiate this denominator. Let u be equals to s squared plus 1. You agree with me? Du over dx will give us 2x. So you can see we have 2s at the numerator. Okay? Now, let's replace this dx. It means du now over 2s equals to dx. So now, we can boldly replace this ds by saying here now, in place of 2s, we still leave 2x. For this one, we already have u for it. In place of this is du over 2x. This we cancel this. What is remaining after that? It's now remaining 1 over u du. Remember, we've established, if you have been watching my videos, that if you integrate this, that is 1 over x ds, you're going to have ln x. So this one is giving us what? Ln u plus c. Now let's replace this u now with the original value. The original value is s squared plus 2. Sorry, s squared plus 1. That is ln s squared plus 1. Or we simply say ln s squared plus 1 plus c. What have you noticed here now? We've noticed that instead of wasting our time, assume this is an objective question with options. You need to take A, B, C, D, say which of them is correct. No need to waste your time. When you see that the derivative of the denominator is actually the numerator, all you have to do simply say the answer is ln the denominator. So you can say ln the denominator. Ln the denominator. That is why this is special. Okay? Very special. Let's approach the second one. This one is 4x plus 4. Okay, let me work it here. This second one, let's work it here. We said 4x plus 4 over s squared minus 2s plus 5 dx. Okay? Now, you will agree with me that if I differentiate this now, I'm going to have the numerator. How? Because if I come here now to say, what is common here, I can bring out 2, right? To remain 2s plus 2 over s squared minus 2s plus 5 ds. You agree with me? Because this time this will still give us this time this will give us this. If I find the integration of this now, I'm going to have this. Because this will give us 2x. This will give us 2. So instead of wasting my time, I will just put 2 ln s squared minus 2s plus 5. Okay? Dx. Unless it is meant to be what? Solved. You are asked to express everything. Then you can now start replacing this one with u. You do du, the s, you replace the s. At the end of the day, you are coming back here. Okay? Now, let's look at this one too. That is 7x over 3 s squared this. You will agree with me. You can simply say, let u be equal to s squared minus 3. So du now over dx is equals to 2x. Okay? Now, we want to replace this dx. But the issue is that if we replace ds, we replace this with u, what about this x? Therefore, that means we are not only meant to replace x, we have to replace s dx. That is, we are not meant to only replace ds, we must replace s dx. So to do that now, that means we have to remove this s from here and put it here. S dx. Now we have something for them, for these guys. So we can now come here now to say for this, in place of these guys, we are going to say 7, that is 7 over 3. This is u. In place of these guys, we have this. That is du over 2. Now, you agree with me, this 7 can come out. This time, this is what? It's 6. It can come out. 1 over u dx. You see? Now, what is that? Ln u. See, what is ln u? U is what? S squared minus 3. Okay? The next question you are asking me now is, why did you manipulate it the way you manipulated the first one? Just go straight to the answer. We can do it, oh, we can do it. Let me show you how I will do it if I don't want to follow this process. I will first of all say, what is the integration of this? I know that the integration of this, remember to put plus c. I will say, the integration of this, on my head, I know that is 2x, okay? So what I will do now, I should have 2s here. That is, what I should have the original would have been 2x over s squared minus 3 dx. If I have something like this, it's a perfect way of jumping straight, but I don't have it now. Because I know that this is the ideal situation, and I don't have the ideal situation, I will simply bring out this 7 and this 3. I'll bring them out. 7 over 3 come out. Now, they are out. I need 2 here. I need 2 here. That is a forgery. To remove the 2, I will bring another 2 here. These 2 will cancel these 2. So, because I am interested in this, I will keep these 2s and bring out this second 2. This 2. I will join in with this one. 2 that I remove here, multiply by this, it will give me 6. I will do all this thing on my head. You see? Now, I now have a perfect situation that will help me with this. So with this now, I will simply do 7 over 6 ln the denominator plus c, which is the same thing with what you saw there. That is the way I will manipulate it. Okay? Now, let's continue. I will ask you to work this out for us. But this is the remaining one. Work this out and share your answer with us in the comment section. Thank you.